In this lesson, we are going to learn the overlapping Venn diagrams, and that is for two sets. So overlapping means when one sets and other sets, some elements are common. So how to deal them and what kinds of theorems can be used for these two sets. So let's begin, and I will show you first what exactly how they look like, overlapping sets. So here I've taken the presentation of overlapping sets using Venn diagram for two sets. Suppose there are two sets A and B, and these two sets overlap. So in the first figure, it is very clear. You can see this is the set A and this is the set B, and this area is overlapping. So how to represent this one and what kinds of formula can be used to solve the overlapping sets problem. So I will show you this example with some numeric example, so it's be more clear here. So here I'm trying to show you the two sets are overlapping. First of all, for overlapping sets, there is a formula. This is the formula A union B. Union means the element of either set A or B or both. I repeat, let me write this, it should be more clear. What's the meaning of union? I'm talking about two sets. Let us say only two sets are available. Then what's the meaning of A union B? When I say A union B, let me write it, it will be more clear to you. Okay, this is not so clear. A union B, this can be written as elements of either sets. Elements of either sets. In other words, this can be said elements of either set A, or elements of either set B, elements of either A or B, elements of set B, or we can say the common elements of both sets A and B, or elements of both sets, that is A and B, sorry, A and B. This is, we need to understand, this is called A union B, and the second symbol I'm using here is A intersection. You can see here is intersection. When I say A intersection B, and this implies the elements of both sets only. Element of both sets A and B, right? So when I say A union B, first of all, you just make a note of this one. A union B is equals to set A plus set B minus set of A intersection B. And this theorem is also known as simplified OR rule, or we can say addition theorem of sets. Addition theorem of sets. How we add the sets. So in this Venn diagram, let's try to see which region is called A union B. A union B region is this, from here to here to here, this complete circled region. This is called A union B. And how about second one, A intersection B? The region which is common in both, don't pick all, the region which is common in both, that is called A intersection B. And one of the interesting case we can take from here, if, let me write here, there is some space, if sets are disjoint sets. When sets are disjoint means there is no common element between the sets. In that case, A union B is going to be set A plus set B. Since there is no common, so you have to subtract nothing. And how the Venn diagram look like then, this could be the set A, and set B is another which is disjoint. There is no common between them, so we can present the set like this. So this is the we can say the overlapping sets for two sets. Condition one, they are overlapping, means there is something common, and second case they are not overlapping, it means they are the disjoint sets, right? Now let's have the closer look for this for union and intersection. We can go here. So we have already discussed what is the union and intersection, but still I'm trying to show you. We can see the closer look for this intersections of the sets. So you see here we have the element of set A, that is 1, 2, 3, 4, 5. You can write here A is equals to 1, 2, 3, 4, 5. And how about set B? Set B you can see 1, 3, 9, 12. 1, 3, 9, 12. So what is the intersection of the sets? Means which is common in both this yellow region, and that is 1, 3. So this can be written as A intersection B is equals to 1, 3. And union, as I told you, union means this complete circled region. So put together anything, whatever comes, that comes union. You can see here it's written A union B is 0. In this, okay, it's not the same sets. So 0, see what's the element of set A? 0, 1, 3, 5, 8, and the set of element of set B 2, 8, 5, 9. So just put together, this one is going to be the union. So we can take one more example. Let me take one algebraic example so you can get this idea in detail. Maybe set A element is A, B, C, D, and set B element is could be C, D, E, F. Now, when we try to sketch the Venn diagram for this overlapping sets, it's be something like this. This is generally we take a rectangle to represent this is the universal set, or sometimes we are using the word the total. Total means includes everything under this discussion. Okay, and now we can take the set A and let us go for set B. So why I'm cutting some region? Because the elements, there are few elements are common. And while you sketch the Venn diagram, you need to take care one thing. First, you try to fill the most common area. So you can see C and D is there in both. And how about this element set A and B? Set A elements is A, B, C, D. C, D already put here. We can write A and B. And how about element of set B? C, D, E, F. C, D is already there. So we can write here E and F. Now the Venn diagram for two sets, two overlapping sets is ready. How about this region? We have never discussed about this. I mean, a region which is under union but outside of A union B. I mean, this overlapping. This is called neither A nor B. Neither A nor B. And other words, sometimes we use word none, because that this region doesn't belong to region A or B, but it comes under union. We can say this region is none. Now I'm going to rephrase this overlapping sets for two sets, that is n of, sometimes we can write this A union B is equals to n of A plus n of B. Let me write here is n of B minus n of A intersection B. What is n? Cardinal number or the number of elements present in set. So here we can see A union B. How many sets we have? Just count here. 1, 2, 3, 4, 5, 6. We can say 6 is equals to n of A. How many elements we have? 1, 2, 3, 4. So we can write 4 here. How many elements are there in set B? 1, 2, 3, 4. So we can write 4 minus how many elements are there which is common? You can see here this region 1, 2. Now you can see 6 is equals to 6. So in terms, I mean the same overlapping sets, I'm trying to see in terms of the number of elements, that's also satisfying. Thank you. So keep watching more video, keep learning. Thank you for watching this video.